Hi, my name is John Helfen. I am an education solution specialist with Autodesk, and today I am finishing up a three-part workshop or demonstration on FEA and dynamic simulation. The first demonstration was basic FEA. The second demonstration was dynamic simulation, uh, and the third will be leveraging the real-world forces generated during the dynamic simulation to rerun the original FEA, leveraging those loads. So just a quick overview, the project I'm using to do this demonstration is a Trebuchet. Historically, they're wooden. I've modernized it for Inventor and created it out of milled aluminum. So hopefully you've seen the previous two workshops or demonstrations. If not, go ahead and step back for a minute and review those, because here we've actually are starting from a point where we've actually run the dynamic simulation and have collected the loads and forces that are generated during the simulation. So to finish up the series, I will enter the FEA environment, or the stress analysis environment, and I will create a new simulation. Now previously we had created just a single point static simulation and we went ahead and clicked OK and started with the defaults. Here, since we've run through the simulation already and we told the simulation to export the loads and forces to the FEA system, we can actually use the motion loads analysis option here in the static analysis section. And when we check that checkbox, you can actually see that the part we exported, the treb arm, which is the arm here in the center, is listed. If we had selected multiple parts, we could select it, they would be listed here as well. After we had indicated that we wanted to export that part to FEA, we went ahead and generated a 25-step series of positions throughout the dynamic simulation, and you can see those here. So we're going to go ahead and just pick somewhere in the middle and hit OK. And what that will do is actually go and move the model into position at that time during the simulation, and it will automatically apply all the loads that were being generated on that part at that point in the simulation. So previously we had actually done the simulation or a stress analysis where we fixed the center point and we just put a single z-axis force on each of the holes on the end of the arm. And here you can actually see much more realistic loads being applied. You can see it's not just a single force. There's rotational and torsional forces being applied. There are external loads being applied here as well. So when you look at this, you can actually just see that there's significantly more information that is gathered from the dynamic simulation than what you might realize needs to be applied if you were to just do the FEA by itself on the arm itself. So since it gathered all that information from the system itself, all we actually have to do is go ahead and run this simulation now. So like I said, if nothing else, if you're headed towards stress analysis, if you can build a dynamic simulation, you're going to end up with much more accurate results, in my opinion, than you probably would have had you just done the static simulation by yourself. So here you can actually see the results of our simulation, and then you can actually see the twisting that will take place in this in this environment with the forces that are applied to this model. Now again, like in the previous FEA demonstration, here we actually have the results scaled. so that you can actually see the change. Let me go ahead and jump it up to, if I bump it up to a 5, you can actually really see how things are getting twisted. Of course, that's not the actual. Let's jump back to the actual results, and you can see that the twisting and the stress applied is actually very minimal. Let's look at the displacement. Yeah, you can see there's some displacement on this end. Let's look at the maximum. We can toggle on our maximum. Yep. Here, you can see on the end is where you're getting the max load. And overall, I would say, let's check the safety factor really quick. Yeah, the safety factor is plenty in this environment using all of the components that are part of this assembly. We are well within our safety factor. I mean, this is, just an aluminum trebuchet actually launching just a little rubber ball. So, we're definitely within our safety factors. So, as you can see, the combination of the dynamic simulation environment and FEA can really be worked together to, generate everything you need to go ahead and evaluate your model in a digital prototyping method. Before we've even cut any parts, we actually get a good feeling of where things can be improved, or whether or not we're gonna everything will pass based on the forces and loads we've applied. So I hope this was useful for everyone, and look forward to presenting to you at another time. Thanks.